Hello and welcome to 3DCS's review of our demonstration models for Mechanical Modeler as of August 2015. The first one I've pulled up is the tutorial model. It's a very simple model. It comes installed with all of the software. It brings together all 4 pistons, and as built it's unconstrained along the rotation of the crankshaft. So it just builds it in a random position. If I wanted to add some motion to this, I would find the move for the crankshaft, use quick copy, and turn it into a motion move. I want to rotate it 36 steps, ending at 350 will give me 10-degree increments, and then I can nominal build and watch it. It's running rather slowly because it's trying to build all 4 pistons at once. If I wanted to speed this up, I could turn off pistons 2, 3, and 4, or I could use the best practices of fixing pistons as I build them. So this has some variation that you can see. It's a nice simple model for showing people the very basics. Yep. So the next model I want to show is the first demo model we did, and we showed this at the global conference a few years back. So this model, this is going to need to be a pause.
You're alright, take your time.
Yeah, I didn't realize. Yeah. So, yeah. So this model takes the rotation of our green switch here and converts it into translation up here and rotation at this banana rocker. And this one actually has a mechanism built in CATIA, so you can delete these moves and show the extraction process for the push button modeling. And also, we have also 3 different ways of controlling this green switch. The first one is the rotation that we saw. The second one is a simple contact that pushes this switch to its maximum rotation. And the last one, I'll show you with I'm going to extract the GD&T to make it clearer. These are exaggerated GD&T callouts. So this last one pushes the rocker to its maximum clearance from this pin there, here. And you can see that maximum clearance is always occurring when when these 2 links are parallel. So I'm going to delete all of these, and now we've got 0 moves. Then if I go to the mechanical toolbar, click on Update Moves, it creates the 11 moves from the CATIA. You can see it actually has 2 inactive contact moves. So right now, nothing's controlling the rotation of that green part. If I want to turn on our move 69, now it's being held there. The motion moves are not automatically extracted. if I wanted to have a motion move, I'd keep these inactive, and I'd find my revolute controlling the green switch, and I'd make a quick copy and turn it into a motion move just like before. So this is our main demonstration model for mechanical, and this model has actually been broken down into several configurations. And we have our big versions that have rotation of the wheel and moving the suspension into jounds and rebounds. And then we have smaller configurations that only move the suspension into jounds and rebounds. And then we also have a model that illustrates a complicated U-joint with the full rotation and transmitting of motion through the cardon. So when you want to, and we also have other ones that aren't saved as official demo models that are used to demonstrate some color mapping and AO functions. So keep an eye on which one you have. Usually you're going to see it in a, it'll be in a folder with, or a zip file with the desired name, and you can see, we're giving you the version number that it was saved in the file name itself. And I like to do that to make it really easy to see what's the top level CATIA product and what you can open it in. So this one, actually, the full or complex versions have 2 active motion moves. So if I nominal build and deviate, you'll see going through jounds and rebounds, and at the same time the tire is spinning around. So this gives you an idea of all the complicated motion you could have in a demo model. It's saved without GD&T on, but you can also extract it in this as well. If you wanted to show any of the kinematic tools, what you'll notice is that you can only have 1 active motion move at a time. So here I've got to pick one of them to go through its steps. Similarly, if you were going to simulate it, you'd be able to analyze one at a time, or you could set both of these to a particular rotation and analyze that with a regular simulation. So this model has some typical measures, and then every measure that starts with VM stands for validation measures. These all prove that each attach point stays aligned. So if I look at, say, the lower arm to the knuckle, it shows that that spherical joint is always attached. So this is one of our most recent demo models. We built it in conjunction with Fazotech. And what it's showing is it's showing a pretty complicated set of motions, whereas our driving trillion turns, it's pushing this cage at different locations. And so you can see the cage actually stops moving when it's at rest, and then it's being pushed by the different features. And to do that, we had a pretty complicated set of moves. These 28 moves are actually divided into 8 sections for the 8 different possible combinations of locators as it rotates around. And you can see I've used a lot of conditional logic, some DLLs, and some iteration loops in order to accomplish all of the different possibilities. So this is a good demo model to show complicated motion, and it's also a good model for your higher level users who need an example of how to change locators. There are some really small tolerances on these parts that can be extracted. They're pretty tight because we wanted a realistic part. And then our last model, it was a specialty model that we made showing a handgun firing. The two warnings that you see, they're not important. They are overzealous and they're going to get removed in the next release. So as it's saved, what this is showing you is the recoil after the handgun's fired, and as it slides back, it shows you the motion of the barrel and all of the mechanism inside. As it's saved, the trigger's already pulled back. You can turn off the trigger rotate move, turn on the trigger motion move, and then turn off the sliding move. There you go. Now it's going to show you the motion when the trigger moves. So this model is another example of using iteration loops and conditional logic in order to accomplish changing locators as the part moves. Different surfaces are going to be touching each other. So I'm hiding the slide to show you a little bit better. So it's pulling the hammer back, and then it's catching on that pin. Then I'm switching back to the first configuration. And you can see your barrels getting caught. And this is riding down, pushing on the hammer here. So I want to thank you for taking the time to learn about these today, and I hope that you find this useful, and please contact DCS if you have any questions. Thank you.